we recorded. I don't use the exact questions. I always paraphrase it. I focus on the concept. So if you have a fire triangle, that's the concept. You'll get a question related to it, or fire tetrahedrons, very common this year. So we'll get on to it. Let's take a look. I'll pull up.
How about you, Larry?
I get the second edition, is because that's what the test is all on right now. And you know, when you get exam core, you get other assessments. Everything's based on the second edition. I'm sure when you get to the third edition, the next iteration of this exam, probably 2024 or 2025, it'll probably have it. Right now, the Yates book is missing violence and personal information issues, and not so much on the ethics, as they're asking the questions now. But it's got, you know, I would say 85% of the stuff is going to be covered on the ASP and CSP, the concepts, and then for the CHT people, it'll have all the fundamentals you'll need for, you know, fire and electric and everything else. Let me see. I can mute somebody real quick.
Do I have my volume on?
Yes, you do. All right. There we are. We're all good now. All right. So, you know, one of the things about fire safety is that people often don't see the hazard of gasoline or fuel. I mean, people would put things in it. These are plastic, you know, canisters, not good for anything. You know, they're really not designed to store. They can leak very easily, and if you're putting it in your car, you're going to have the fuel in your car if it vaporizes, you know, which is no good. You know, but people are, you know, when they have a shortage or there's a power outage, they're trying to, you know, get fuel for a generator, and this is not very good. So when you get into the area, let me have one more person to mute. Okay. The fire safety is going to be in all major tests, and you know, it's in different domains. When you look at it, I'm always surprised, you know, when I see these big hotel complexes catch fire on the roof. You know, you think about, this is an area with a roof where people might be at a pool or a outdoor restaurant on the roof, and it can catch on fire, even though you would think, wow, how could it go? Well, you know, anything plastic can burn. So if you have plastic displays and you have, you know, dried plants, that's all fuel, and all we need is the ignition source. So one of the things that they ask a lot of times on the test is, maybe you'll get one question on a definition, and OSHA is the basis of a lot of the questions. The safety can is going to be something that has a self-closing lid, and it can relieve pressure so that it's not going to explode. It doesn't become like a glass jar or something. If it gets high, it's just going to explode. It's just going to relieve pressure, and then the can has got a very big spring lid that'll close on very safely. The flame arrestors are in a lot of cans, and all it is going to take the flames, force it through the tubes, and then the gas comes out, and it's not going to create a fire. And almost all the time you'll see things like funnels with flame arrestors. If you just buy what you use in a store for your car, that won't have a flame arrestor, and that becomes an issue of, it can, you know, create a black flash and a fire right through it. You'll see flame arrestors used in welding cables and other things for oxygen acetylene welding. So flash point are some of the terms they're going to ask. You can start the liquid on fire. It's usually done at room temperature. They use what they call the Penske closed cup test. You don't need to know that, but it just, you know, they're just trying to ignite the fuel at room temperature. The autoignition temperature is where it will actually start on fire based on the temperature alone. Usually you're not going to get your fuels do that, otherwise they would light on fire at the gas station. Autoignition temperature liquids are usually like the ethers, you know, very much solvents or very much flavorings in that, you know, food industry. They'll use ethers because they like them. They dry very fast, but also they are very flammable and can ignite on temperature. The boiling point means, just like you're cooking the water, it goes at 100 degrees Celsius or 212 degrees Fahrenheit. That means it's going to actually boil and evaporate to a liquid. Now, the lower explosive limit is used in confined space in several parts of the standards. It means that we have enough fuel to start the fire. We have oxygen, we have the fuel, and we have the ignition source. and all we need is that ignition source. If we have 0.0% of gasoline, it won't light on fire. Even though we have just some in there, it's too lean, as they call it. So once you get to gasoline, 1.4% of it by volume in air is enough to ignite, and it'll be combustible. If we put 100% gasoline vapor, we can't actually ignite it because it's got no oxygen. You have to have oxygen in fuel to start a fire. But that'll be what they call the upper explosive limit, is where it will stop being combustible. You can't ignite it because it's too fuel rich. The term that's coming up in NFPA, and it's dealing with this GHS, Global Harmonization System issue. When they came up with the pictograms for fire, they dropped off combustible liquid, which was a mistake, because I've had several combustible liquid fires that have hurt people because the container does not say it's combustible liquid. That could be either diesel fuel, kerosene, charcoal lighter fluid, and so on. People are spraying it all over on the floor. The liquid evaporates into the vapor, and the vapor ignites, and then they get caught in a flash fire. So NFPA is trying to get rid of the word flammable, combustible, and call it ignitable, and then try to get the UN GHS committee to put the pictogram on any ignitable liquid. So that's been a battle they've been fighting for 12 years, and so they're going to just say that if you can ignite this liquid, then that's going to be an issue that they would want a fire pictogram, and that I think is a good idea. So you may hear that term. It's not on the test yet, but I just bring it up because there is a difference between flammable and combustibles. Now the test is still in the NFPA 1A, 1B, 1C for flammable liquids. It hasn't gone over to the category 1, 2, and 3 from GHS. There are questions that have category 1 flammable, but I haven't seen too many of them. Most of them still seem to talk about the category 1B in all the assessments I've seen. Again, category 1, that's your ethers, going to be low flash point, boiling points below 95 degrees. That means it's going to be usually used in food for flavorings. Category 2 is your fuels, like your gasolines, your toluenes, xylenes. Almost all your flammable solvents for paint are going to be in the category 2 liquid. They call them the CAS 1 in the NFPA. Category 3 is a rare chemical. I see it like maybe 1% of the time on the chemicals that'll have a flammable symbol. It's not that common, but it's a flash point over 73 but below 140 degrees. Now, one of the things you'll see is OSHA different numbers from NFPA. That's one of the problems with that. OSHA took the 1969 code and made it law. NFPA's changed the numbers, so that becomes an issue of why NFPA wants to go to ignitable instead of just trying to sit there and say it's a hazard. Category 4s are your combustible liquids, and again, everybody agrees on that. They've asked this question, what is a combustible liquid, and they'll give you some flash points and boiling points, and that's just an odd question, I think. So this was a exam core type of question. I just changed the answers around. Which is a characteristic of a 1C liquid? Now, this is the problem. I went over it, but I didn't go over it and read it word for word. This is what you'll get into it, and usually you can narrow it down to 1 or 2. So we'll take a look at it. Type in the chat what you think the answer is, because this one's a tough question. I was surprised to see this on the exams, and that's because I don't see too many of these 1C. I was surprised to see it. We know we can throw out D. Okay, very good. C is the answer. You can throw out D because it's a flammable. Flammables are not going to be at boiling point. You know that's not going to be true. It just becomes an issue of which one, but it's C is the correct answer. They're going to ask you a little bit about the alarm systems. There's different ways to notify people in case of a fire. You're going to have an emergency action plan, and that's not in this module, but there's going to be bells, horns, and sirens. My problem lately is these sirens and alarms are 140 decibels. 140. OSHA says you can be at 15 minutes at 115. You can imagine what 140 is. It's deafening. I mean, I remember hearing one, and I was a place I had to put the earplugs in because I was going to have ear pain just from the trying to get out of this building, but that's way too loud. Okay, fire extinguishers in egress, you're always going to get questions. Here we're using what we call an ABC fire extinguisher on a flammable liquid. They may ask you about the pass system. Pull the pin. Where do you aim? This is a question that comes up. It's not on my question. Where do you aim? Because the base of the fire, not the center of the fire, which I just had an incident in July with a company where they were aiming at the base and they didn't put it out. Aiming at the center. Just went right over the fire into the back of the wall and didn't do anything. You have to aim at the base. Fire extinguishers got to be accessible. So if you put it up where people can't even reach it, or they've got to, pull up both arms, that's not a very good idea. They got to be marked and they got to be identified. So there always going to be a question on one of the type of fires. And a fire I always call the ash fire. It's going to leave an ash. It's going to be cardboard. It's going to be wood. It's going to be paper. Pretty simple. Water was used for years, but now the ABC powder is going to be there. Class B is our boom or our fire is going to, it's going to explode or it's going to catch on fire. Flammable liquids and compressed gases that are flammable, like acetylene, would be a Class B fire. Class C involves electrical current. So most people think of generators and transformers fires that they see on the media. That's an example of a C fire. Class D is coming up with a vengeance. What metal is the #1 cause of a Class D fire right now in the last year? It used to be magnesium and aluminum, but one is just overwhelmingly now. Anybody know? Not titanium. Think electric vehicles. Lithium. Very good, John. Lithium fires. Lithium fires cannot be put out with an ABC fire extinguisher. What actually, if you take a Class D fire extinguisher, which costs like $500, it's expensive. It's essentially graphite and salt mixture. Graphite is a carbon powder. You spray this, you're going to have black dust everywhere, and it's got salt to help kind of char it. So there are a lot of researchers trying to make Class D fire extinguishers much more affordable because, if you got all these cordless power tools, electric vehicles, you're going to need a Class D fire extinguisher in your facility. As facilities go to, company vehicles that are electric, that is a fire that they're going to have to be able to plan for. If you ever seen these videos of Tesla catching on fire, the fire departments have a hard time because the fire's under the car and the batteries are going to generate so much heat this ABC fire extinguisher will not work. Class K came up in the last 20 years and is for cooking with a K. The idea is that I've been involved in several deep fat fire incidents over my life, and if you take an ABC fire extinguisher, it just rolls. The liquid's boiling and it's rolling and it doesn't really stop. The K comes out and kind of sits on top of the fire, but you really just got to shut the power off and kill the source of the heat because usually it's electric that's causing these grease fires. So here's an example. They put the lithium iron battery, and this is a DeWalt tool, and they tried to use it, and essentially it doesn't do much. It's going to be moving the powder away from it. It just keeps on going in there, and it's very smoky and very toxic. So that's a problem. There are somebody that they're talking about maybe trying to use sodium chloride, which is salt. My experiment, I hope to do this year, actually next week, is to try to get one of these lithium batteries, light it on fire, and just put a bag of salt on it and see what it does, because I haven't seen anybody do that. But fire triangle is what we started with 100 years ago. You had to have oxygen, heat, and fuel. If you don't have one of those three legs, you don't have the fire in an area. You'll get a version of this, in questions all the time. Lately, the fire tetrahedron's been coming up, and I was surprised because it kind of didn't show up for it. You got to remember, the fire questions are probably 200 to 300 in the bank, and you're going to get so many of them, and some of them come up more frequently than the others. But it's the chain reaction, and if you ever had a halon system, which was very popular in the 70s and the early 80s to put out computer electrical fires, the halon would interfere with the chain reaction of combustion and stop it. it would be about 7% halon in air, which means you could breathe it. I've been in halon environments where it's been, the extinguisher discharged or the suppression system discharged, and it feels very much kind of like an ozone, kind of a irritating chlorofluorohydrocarbon taste to it, but not lethal, not exactly probably the best for you, but because of the environmental issues, it became kind of like pushed to the side, and you don't see it too much. So there's always distance questions. For your combustible metals and water, you got 75 feet to get to them. I've actually seen the question where they ask that if your flammable liquids are going to be B and C, then it's going to be 50 feet. They have to have a monthly inspection, and they'll talk about what kind of things. You're going to check the extinguisher to make sure the pin's there. For example, in this photo, you're doing the monthly inspection, the pin is gone. It's not good. The fire extinguisher is in the red, so that means the extinguisher has been discharged. You should be able to catch that every month. And most people put a tag on it to do this. The annual maintenance check we'll talk about. Generally, you're going to make sure the hydrostatic testing, everything is good, there's no rust, no corrosion. I flip up the extinguisher. So I'm just going to stop the screen real quick. I just take the extinguisher like this, and I could feel the powder. And one of the things I notice when I do this one, the powder comes as if it was a rock. I can feel that the powder moved as a chunk. So what that's telling me is that extinguisher has probably got like a cake of that yellow powder. It's not evenly distributed like sugar or anything else. It may come out and just the propellant and some of the powder come out, but a lot of that extinguishing is now in a big solid ball, and it's not good. So we're going to have to replace that. That's it, a typical, typical monthly or annual inspection that you would do. Remember, monthly is a visual, annual, you're going to pick it up and look at it. Okay, share screen. So the 4 elements to start the fire, a little bit different. What do you think? A, B, C, or D? Put in chat. A, B, C, or D? Very good, John. Thank you. Okay. So the answer would be D. Remember, all dust is not combustible. Lead dust is not combustible. So that would be why you would throw lead. But this is the trouble. Always read through the questions, all 4 of them, because it's very easy to see the first one and then say, oh, that's it, and not read the last one. And if you had combustible dust, that would be a correct answer. You have to educate employees on different types of fires, as and the stages of it. They're going to use the word excipient. I always call that the garbage can fire. It's a very small fire, smaller than you are, and it can be put out with 1 fire extinguisher. And that's what I call incipient. When it's over your head, you always have to plan for an escape route, when using a fire, because the last thing you want to do is be trapped between the fire and the exit. Okay, how far travel distance for the A fire? A, B, C, or D? And people think, you have to really remember the numbers? Yes, you do, for these fire questions. Everybody's guessing flammable liquids. It's 75 feet. 75 feet for A and D, 50 for B and C. Okay. So everybody who's going to use a fire extinguisher should have an educational program. Everybody should have initial training on what to do in case of emergency initially, and then every year afterwards. That's one of the few requirements in OSHA. I would never do this as a trainer of fire extinguishers. This is dangerous. You light a gasoline on top of a milk crate, and you're going to put it out and practice it. You can imagine what could go wrong, if this milk crate melts, the fire can go right toward that vehicle, and next thing you know, you've got a very expensive vehicle to replace, So I always tell people, you know, I just practice. We want to get to the base of the fire. We just put an X. I want to be able to see the X being obscured by the fire. Again, when you do this training, this powder is kind of like a silica in a way, and you have to plan for that to be on everything that might be in the area. So you want to do it outside. And I always do hands-on training, because once you do it, you'll never forget it. It's one of those things that people, once they get used to it, even if they shoot high because they're trying to say, I'm not used to ever using it, 95% of people I train have never used one in their life. And so if they go up there and they aim at the green sign, they'll very quickly figure out how to move it down within a half a second or a second. And these things will usually shoot, 17 seconds on a small one, so they, most people can do it. And I've had several people who've been my students actually put out a fire in the facility, which, believe it or not, one of them saved the facility, because, the fire was 8 foot, and I thought, well, that's a little bit beyond a recipient, but he started at the base of the fire and it went out fairly fast, Remember, because it's tall doesn't mean there's anything burning, it's just a flame, So he put out the base, and that started and saved the plant, and that was good, Fire extinguisher, what are they gonna say here? Over here, what are they gonna say about this extinguisher? You can see it, but there's an issue. It's blocked. Poor access, yeah. Because it's seconds, it's seconds. There's plenty of videos to show how fast they can go through it. Boy, this is a long question, and this is what I hate on the exams. What is a minimum requirement for a fire external examination to detect physical damage, corrosion, nozzle blockage, verify operation are present, legible, and the HIMS system is present, legible, and determination of the 6-year interval for hydrostatic testing? Wow. That's a long question. What do you think? Very good. It is 12 months. This comes from NFPA 10. NFPA 10 is a portable fire extinguisher standard, and they define what is an annual inspection. So this is like word for word out of NFPA 10, and you'll get a version of that. But it's a detailed inspection. So in OSHA, it says you got to do an annual inspection. It doesn't really talk about how detailed it would be, and this does in NFPA 10. Every 12 months. So the fire detection systems have come up on the ASP. For those that are going to take that, that's been an issue. You won't see it usually on a CSP or CHST test. But the distinguishing area has been, what is the types of detectors? And we'll talk about that. There are 4 different types. There's rate of rise. That means it's sensing the rate of the heat coming into the building, and as the temperature rises, it's going to detect and then send the alarm. 70 degrees Fahrenheit, and if it goes up a 15-degree increase in less than a minute, that's a rate of rise. Okay. The heat detectors are bimetallic strips. As one temperature goes up, one metal starts to bend and curve, which then triggers the alarm and focuses on the actual heat. A lot of them 135 degrees. People think, well, wait a minute. That seems very low. Well, you could buy ones that are higher, but 135, your room shouldn't be 135. You can't work in an office at 135. You're going to be dying. You can be outside and it could be 135, but, that's a different issue. So there's photoelectric. The photoelectric shoots a beam. The smoke obscures the beam, sets the alarm. Pretty simple. Ionization. It's got 2 metal plates that are charged. The smoke interferes with the charged plates, which ionize the air, and then that causes the flow to be disrupted, and that sends the alarm. Which one detects a difference in the light level from the light source? This is an actual ASP type of a question. Very good. C is the answer. Photoelectric detector. And that's, like I said, that's an odd question, and again, this was an old question. I've been doing this for 20 years. Back then, it was a very common question. Then it kind of disappeared about 5, 7, 10 years ago, and now it seems to be coming back. More students are talking about. Yes, go ahead.
Yeah, John, but in few of the questions which you have posted on the group, there sometimes they ask if there is a warehouse or some kind of installation. So, which type of detectors are best to install? So, how to tackle those kind of questions?
Well, in a warehouse, you're going to be in a large area. So smoke will go up. You hopefully would put it above the packages. Whether you use rate of rise or photoelectric, I would say photoelectric would pick the smoke up faster. Rate of rise, because you may have 60 feet high area, it could take a while before a 15-degree difference comes up. So, I mean, there's no magic formula, but I would go into the photoelectric because it would pick up smoke faster. Because it should be no smoke in the warehouse. The types of suppression systems. Well, there's water is the most common. In the electrical rooms, I've run into carbon dioxide, CO2. Floods the area. You can imagine if you're in this room, it won't activate automatically. It'll give what they call a pre-discharge alarm of 30 seconds usually. Sometimes a minute, depends on what they've set it to. Because when this thing floods, it's going to give 100% of carbon dioxide in there and 0% oxygen. So if you're in this room, when you're in this position, you're in bad trouble. You are going to be suffocating from the lack of oxygen. Asphyxiation is what the lack of oxygen is. The foam systems, they're used in the big aircraft hangars is where I first saw them all the time. But it's a deluge system. It's going to go into foam. It's going to coat everything from the airplane to the generators, and it's going to bury it under a wall of foam. The theory is it's going to block the oxygen. It's going to cool the material off. But they're finding out some of these chemicals in the foam are hazardous and cause cancer. The 4 types of sprinkler systems. The ASP will ask you this. You won't have to know it for the other ones. Everybody has to know how far the material has to be stored above the sprinkler. How many inches is required to be cleared on every sprinkler if you're going to put storage above it or below it? Below it. Anybody know that number? How many inches below the sprinkler can you put your rack storage? Okay, we'll talk about it. Let's go into the wet type systems. Wet type is the most common one you'll see in almost all your buildings you go into. It's filled with water. There's a fusible link or a little glass liquid in it sometimes. If it melts at a certain degree temperature, and there's anywhere you can set it for 135, 150, there's all these different ones that'll burn at different temperatures, then it floods that sprinkler. If that's the only area where the fire is at, that's the only sprinkler head that's going to go off. The dry pipe is always used in a cold warehouse, because if you put freezer storage, that sprinkler pipe will be frozen solid if it's got water. So the dry pipe system is going to have air or nitrogen in that pipe for that cold area, and then when the alarm activates, it's going to release the water to put it in. So they'll always ask you what type of system would you want to use in a freezing refrigerated warehouse type of thing at 20 degrees Fahrenheit or minus 10 Celsius. It would be the dry pipe. Pre-action means we have to do 2 things. Now this is going to be used a lot of times in the museums and computer rooms where the product is very valuable. So you can imagine, I'm going to be at the Facebook data center today. You're talking, $200 million of electronic computers. You cannot put a water system and blow that whole system out. So they're going to put it in there for an area where the sensor is going to pick up there's a fire, there's going to be a visual confirmation possibly, and then it's going to activate that head. It's going to be designed. That's why it's called pre-action. It's not going to be there and activate on its own. It's going to have a system where the alarm's going to go there. And it could just, you can even have them like in some of these buildings where it's going to just make this a horrific alarm for the person at the station and the area until they deal with it. They can acknowledge it, but it's going to ask kind of permission. You can have it activate on the detectors, but the idea is it's going to have a detector, sends the signal, and it activates. And whether you get involved or not would be in there. Deluge systems, very much going to be in the chemical plants, power plants, and the aircraft. Usually a foam system. It's going to flood every extinguisher. I mean, every head is going to open at once. It's going to flood that area. Used in combustible dusts, like in some of these areas where there might be coal dust, where they just want to flood the area. They don't want to have one sprinkler head open at a time. They're just going to flood it out because the system wants to try to minimize a possibly explosion. Okay, which system is mostly installed in the cold warehouses? What do you think?
5C.
Okay, very good. Oh, false actuation is always an issue. That's always an issue. And like I said, these data centers. I mean, these computer servers that are out there are, each one's $1 million, and you got 200 of these things. It's, it's not like you want to get this thing wet and have to do it. Any questions on the material? Exactly 30 minutes on the fire side. Those are the most common ones that we're going to see.